Okay, so this is how you do problem number 55 on the chapter 17 homework of current and resistance. So, what do we know? We know that the car has a 12-volt battery with a total energy storage of 2 times 10 to the 7 joules. Okay, the first part of the question asks, if the electric motor draws 8 kilowatts, what is the current delivered to the motor? So for the first part, we can just use the formula P equals IV. So, and we can isolate the I value and we can make it power over voltage. Since we know that the power is 8 kilowatts or 8,000 watts, and we know that the voltage is 12 volts, we can just divide both values and we get a value of approximately 667 amps. The next part of the question asks if the electric motor draws 8 kilowatts as the car moves at a steady speed of 20 meters per second, how far will the car travel before it is out of juice? So this is a two-part solution. So we can use the formula power equals energy over time, and if we algebraically manipulate this, we can get time equals energy over power. Now, we know that the energy stored in the battery is 2 times 10 to the 7, so we know the energy. And an important conversion, we know that the electric motor draws 8 kilowatts. And 1 kilowatt of power equals 1063 joules over seconds. So 8 kilowatts of power would equal 8 times 1063 joules per second. So we plug that into a calculator, do all the math, and we get 2.5 times 10 to the 3 seconds. Now we can use the formula distance equals rate times time. We know that the car is traveling at 20 meters per second, and we know how long it is traveling for. And you plug that all in, multiply it all out, and you get 50,000 meters or 50 kilometers. And that's how you do problem number 55.